Hey everyone, today we're going to be learning about rewriting or converting these standard quadratic form equations into vertex form, which will make it easier to graph. We're going to do all of this by completing the square. So if you have not already watched the completing the square video, I want you to go back to that because that's the foundations for what we're going to be doing here. This is going to be one step up and a little bit harder for you to do. I think you'll get through it if you haven't seen it, but if you're struggling on these first two examples, please do go back and take a look at that as I think it'll help. So our first equation we can see is not factorable. The way I know this is not factorable is because there's nothing I can multiply to positive 6 that will add up to positive 2. So when this happens with a quadratic, we have to rewrite it by completing the square. And completing the square just means that we're going to add a number into this equation that's going to make this equation factorable so we can rewrite it into vertex form. So the number we're going to add is going to be placed in front of our constant or our C value. And our C value in this case is 6. That's our independent number that's by itself. And if we add something to the equation, we have to subtract something from the equation. So you can think about this like giving your friend money. If you give your friend money, they have to pay you back for it to be equal. We're trying to keep this equation balanced. So if we add something to the equation, we have to subtract that same thing from the equation so we don't just change the equation because you can't just change it. However, if I hand you $1 and take it back, nothing has actually happened. So that's what I'm doing here. So if I add 100 into this thing, but I take 100 out, I haven't actually done anything that affects the equation. So that's why we're able to do this. If you remember in the previous video, we talked about figuring out what that C value was, right? So we have this blank here and we'll have our first two terms, right? So we have the x squared and the 2x. And we have to figure out what goes into the blank that will make this factor square a perfect square. And to do that, you take half of your middle number and you put it in the top and the side. So half of 2 would be 1. So we'd put 1 on the top and the side, and we'd get 1x and 1x. This is completing the square because our sides are identical. And as you know, the length and the width of the square are the same, right? So if we're doing a square, they need to be the same on the top and the side. So in our blank here, our C value is going to be the positive 1 times the positive 1, which gives us 1. So in our blank, we have a 1. To find this blank, if you don't want to go through the whole process of writing out the square, you can just say this is half of your middle number squared. And what I mean by that is we can look at our 2. Our 2 is our middle number, this value right here. We can say, well, half of 2 is 1, and 1 squared is 1. So I'm going to add 1 into this equation. If I add 1 into this equation, to keep it balanced, I have to take 1 away from the equation. So I'm also going to subtract 1 from this equation. Again, I haven't done anything to this equation. It stays all balanced because I took something and put something in at the same time. But what this allows us to do is it allows us to take our first 3 terms that are right here and swap them out with the x plus 1 times x plus 1, right? Those are the same thing because this is just the factored form of x squared plus 2x plus 1, right? That's the same thing. So all 3 of these things that I've highlighted, they're all the exact same thing written in different ways. We still have a 6 minus 1 left over at the end, and positive 6 minus 1 leaves us with positive 5. Now, it doesn't quite look like vertex form yet, and you'll remember if you watch that completing the square video that x plus 1 times x plus 1 is the same thing as x plus 1 squared. And I can just bring down my 5. So this x plus 1 squared is the same thing as x squared plus 2x plus 1, which is the same thing as x plus 1 times x plus 1. It's just written as x plus 1 squared. So that is how you rewrite into vertex form by completing the square. I know that was a kind of a lot, so we're going to do another simple one like this before we graduate to the more complicated problems that we're going to have up ahead. Let's go ahead and do it. Okay, Here we go. We're not going to do the square off to the side. If you're struggling with this, please go back, but I think we'll get this under control. We're going to go ahead and complete the square. So to complete the square, we have x squared plus 10x, add a blank, move your 4 over, and subtract a blank. Now in my first blank, I'm going to have half of my middle number squared. Half of 10 is 5. 5 squared is 25. If I add 25 into this equation, to keep it balanced, I have to subtract 25. So I'm going to subtract 25 on the end. Now I can replace my first three terms, my x squared plus 10x plus 25, that trinomial, with a factorization of it, right? So I can say y equals, this would be x plus 5 squared. Remember, that's half of 10 is the 5. That is my first three terms. I would still have negative 4 minus 25 left over, which would add together to give me a negative 29. So my vertex form of this equation is x plus 5 squared minus 29. Okay, we've done two simple ones that do not have a coefficient. Now we are going to try something slightly harder to make sure you understand the concept once we start applying different numbers in front of this equation, okay? Let's go here. The coefficient of this equation is 2. When we have a coefficient, that's our a value, we have to pull it out before completing the square so our vertex form looks correct. So let's go ahead and do the first step by moving that positive 6 over. Okay, now that we have that positive 6 moved over, I'm not actually going to complete the square quite yet. Before I complete the square, I have to remove the coefficient so that I can write a correct polynomial, okay? So I'm going to remove the coefficient off of this term and this term, so the first two terms. What that's going to do is it's going to give me my x squared by itself. My coefficient, you might remember, is 2, and what I'm doing is dividing these terms. This is essentially undistributing your terms. So 2x squared divided by 2 will leave me with x squared. 8x divided by 2 will leave me with 4x. I'm going to bring down my blank. I didn't touch that 6, so I want to leave that 6 out of my parentheses and leave my subtraction out of parentheses as well. So just to reiterate, I pulled off my coefficient of 2 from my first two terms, and now I have x squared by itself. Now I can properly complete the square. So I can take half of my middle number, which is 4. That's going to be 2 is half my middle number, right? And I can square it. So 2 squared is going to give me 4. So I'll put a 4 in that first blank. But here's the challenging part. We're not actually going to subtract 4 here. Because we have a coefficient of 2, we have to multiply our 4 by our coefficient because we have to redistribute the 2 back in. You can think of this as me giving my friend $4, but me giving them $4 twice. So if I gave them $4 twice, I actually gave them $8. So if I gave them $8, they really owe me $8 back. So to keep this equation balanced, since I didn't actually add a 4, I actually added an 8, I have to subtract 8 from it. Hopefully that makes sense. Now that this is all written out, we can change this into our vertex form. So the coefficient will just stay in front. Your trinomial will change to x and then half of your middle number, so half of positive 4 squared. Left over, we have these final two terms, 6 and negative 8, and 6 minus 8 is negative 2. So we'd have the vertex form with our coefficient as 2, x plus 2 squared, and then minus 2. Lots of 2's there. I acknowledge this was a very hard problem, especially for your first one, so I have a whole bunch more examples. Let's keep working through these, and hopefully it'll start to become clear as we work through these problems. You're doing great. Okay. This next one, we have a coefficient of 2 again. So your first step is to move your c value, so that's a positive 1, out of the way. Okay, we add a blank in front of it, subtract a blank behind it. Because we have a coefficient of 2, we have to remove the coefficient of 2 first before we complete the square. So the 2 will come out front. We're dividing this term and this term by 2. So we'll be left with x squared, and negative 4x divided by 2 will give me negative 2x. Bring down your blank because we're going to complete the square. Leave your 1 and your subtraction out of the parentheses. My first blank is always half of my middle number squared. Half of negative 2 is negative 1. Negative 1 squared, that's negative 1 times negative 1, is a positive 1. I didn't actually add 1 to this equation. I added 2. Or I gave my friend $1 twice, right? Because I have this coefficient out front. 2 times 1 is 2. Since I added 2 to this equation, to keep it balanced, I have to subtract 2 from the equation. Now I can finish writing my equation in vertex form. So I'll say y equals, my coefficient is 2. My x squared minus 2x plus 1 can be written as x minus 1 squared. And my minus 1 comes from half of my negative 2. And then 1 minus 2 will give me negative 1 on the end. And now I have it in vertex form. Okay, you're doing great. Let's keep going. We're getting into slightly bigger numbers here, but you've still got it. Our coefficient on this equation is going to be 3. So your first step is to move that 9 out of the way. Then you're going to want to undistribute or remove your 3. Complete your square, and then write it in vertex form. Let's go ahead and do it. So we're going to say y equals 3x squared plus 12x plus a blank plus 9 and minus a blank. We have to remove the 3 from our first two terms. So we're going to say 3 times x squared, and then 12 divided by 3 is going to give me 4x. Keep your blank there. We'll add 9 and then subtract a blank. Our first blank is going to be half of 4 squared. Half of 4 is 2. 2 squared is 4. It's actually not a 4. It's a 3 times 4. So doing something 3 times, right? 3 times 4 is 12. So I actually added 12 into this equation. To keep it balanced, I have to subtract 12. All right, let's rewrite it. We'll say y equals our coefficient, which is 3. The trinomial here can be replaced with x plus half of the middle number squared. And then left over, we have 9 minus 12, and 9 minus 12 is negative 3. Okay, if you're able, I want you to try to pause this video when I pull up the next problem. Try it on your own and then check your answer when you're done. If you're still struggling, you can just watch me do it. I just think it'll help if you go ahead and attempt this one on your own. This one is our biggest coefficient yet. Our coefficient here is 4. So let's go ahead and push that C value of 5 out of the way. Once we do that, we can remove our coefficient. Our coefficient is 4, so our 4 needs to come out front. We'll be left with x squared. 24 divided by 4 is 6, so I'll have plus 6x. Leave our blank in our parentheses, bring down our 5, bring down our subtraction. To fill in our blank, half of the middle number squared, so half of 6 is 3. 3 squared is 9. It's not actually a 9. It's really a 36 that I added, because 4 times 9 is 36. So if I added 36 into this equation, to keep it balanced, I have to subtract 36. All right, last step. Let's rewrite it. We'll see y equals 4. You can take this whole thing, replace it with x plus 3 squared, and then negative 36 plus 5, or 5 minus 36, however you want to think about it, is just negative 31. And that is our vertex form right there. Okay, we have one more problem. You are doing great. Let's go ahead and finish this out strong. Last problem here, your challenge is that the coefficient is going to be negative. So you're going to have your very first negative coefficient. This is going to be the hardest one of all. Let's see if you can do it. We're going to go ahead and move over our C value of 1. -1. I think I said 1. I meant -1. Then we have to remove -3. Our coefficient's -3. So keep in mind we're working with a negative here, right? So we're going to be left with x squared here. 12 divided by -3 is -4x. Add your blank, subtract 1, and minus your blank. In your blank is half of -4, so -2, and -2 squared. So -2 squared is going to be 4. It is not actually a 4. It's a -3 times 4. And -3 times 4 is a -12. So if I added a -12 into this equation, I need to subtract a -12 from this equation. And what's going to happen if I subtract a -12, it's really going to be adding on the end. So when you have a negative, you're subtracting a negative, right? It's going to be addition. All right, last step. We'll say -3. We can replace this with x minus 2 squared. And then -1 plus 12 will be positive 11. All right. That's it. That's about as challenging as those problems will get for you. I hope all this made sense. Good luck. Keep practicing. If you need to go back to completing the square video to get a better fundamental on completing the square, please do that. But if you're ready to move on, you can jump to the quadratic equations in standard form, graphing those. You can jump to the hard video. So you can jump right past the easy one, go straight to hard, because this is what we're doing in the level hard.